All right, scientists, this is how you use the energy equations to calculate the energy of your prototype rocket at its max velocity and maximum height. So we can see we already have data up on the screen and the equations we're going to use. We're going to start with kinetic energy, which is equal to half the mass of the object multiplied by its velocity squared. So to do this calculation, you set it up like this. Start with that half, that's 0.5. Then multiply that by the mass. Now the mass is in kilograms, 0.02 kilograms. That is 20 grams. Multiplied by the velocity squared. Now I will write the velocity squared like this, 23 times 23. Now I left the unit out just because I wanted to fit on the screen. Okay? If you multiply that through, this is what you get. 0.5 multiplied by 0.02 multiplied by 23 multiplied by 23, 5.29. Okay? And the unit for that is joules, or J. So at its maximum velocity, this rocket had an energy of 5.29 joules. All right, so that's the kinetic energy calculation. Just written out like that, so you're just multiplying through to get your answer. Now let's make this go away. Potential energy is equal to the mass of the object, which will be the same, multiplied by acceleration due to gravity, which as you can see there is a constant listed at 9.98, and then multiplied by the height. And for this rocket, its height was 15.6 meters. So your calculation is going to look like this. Potential energy is equal to mass, 0.02 kilograms, multiplied by gravity, 9.8 meters per second, multiplied by the height, which is 15.6 meters. And if I do that math, here's what I get. 0.02 times 9.8 times 15.6. 3.06 joules. Okay? So that's less energy at its maximum height than it had at its maximum velocity. Hope this helps.